Regarding the provision for automatic disconnect, the last sentence of National Electrical Code section 682.11 does not specifically require an automatic means to disconnect the service equipment. It states that circuit breakers used as service equipment shall be marked suitable for use as service equipment. Circuit breakers so marked may be used as service equipment in accordance with the provisions of this article. This suggests that circuit breakers can be used as service equipment if they meet the requirements of the article, but does not mandate an automatic disconnect. However, National Electrical Code section 682.13 requires that outdoor service equipment shall be installed in readily accessible locations either outside the building or inside the building at or near the point of entrance of the service conductors. Given these factors, it is reasonable to conclude that an automatic means to disconnect the service equipment is not required in this scenario, but the control equipment should be located in a readily accessible location for manual disconnection. Now let's discuss the equipotential plan. National Electrical Code section 682.33 subsection A requires that in addition to the grounding electrode system required by section 250.52, an equipotential plane shall be formed to the service equipment. Part C of this section states that the equipotential plane shall be connected to the grounding electrode system and to all non-current carrying metal parts within 6 feet of the grade level adjacent to the equipment. The bonding grid for the equipotential plane does not need to match that of 680.26 subsection C, but it should be designed to provide a low impedance path for fault currents and to minimize any potential difference between metal surfaces within the restricted area. Acceptable methods for creating an equipotential plane include using a metal grounding mat, concrete encased electrodes, or a metal grid buried beneath the surface. Therefore, both the control area and the service equipment areas should have an equipotential plan created, and the plan should be connected to the grounding electrode system and to all non-current carrying metal parts within 6 feet of the grade level adjacent to the equipment. To elaborate further on National Electrical Code section 682.11, its primary focus is on the location of service equipment. This section permits the installation of service equipment in specific areas near bodies of water, provided certain conditions are met. These conditions are designed to minimize the risk of electrical hazards associated with water and to ensure the safety of individuals in and around the water. The key consideration here is that while the section allows for such installations, it does not mandate automatic disconnection. Instead, it emphasizes the use of appropriately rated and marked circuit breakers and the accessibility of the disconnecting means. The absence of a mandatory automatic disconnect provision is based on the understanding that other safety measures, such as proper grounding and bonding, equipotential planes, and readily accessible disconnecting means, can provide adequate protection. The requirement for circuit breakers to be marked suitable for use as service equipment ensures that these devices are designed and tested to handle the specific demands of service applications, including the ability to interrupt high fault currents. The readily accessible location of the disconnecting means allows qualified personnel to quickly and safely de-energize the circuit in case of an emergency or for maintenance purposes. Now let's delve deeper into National Electrical Code section 682.13. This section addresses the placement of outdoor service equipment, emphasizing the importance of accessibility. The rationale behind this requirement is to ensure that service equipment, which includes the main disconnecting means and overcurrent protection devices, can be easily reached for inspection, maintenance, and emergency operations. The accessibility requirement is satisfied if the equipment is located either outside the building or inside the building at or near the point of entrance of the service conductors. This proximity to the point of entrance minimizes the length of unprotected conductors inside the building, reducing the risk of faults and fires. In the context of a submersible pump installation near a body of water, the location of the control equipment on a concrete pad 10 feet from the shoreline is considered an outdoor location. Therefore, the equipment must be readily accessible, meaning it should not be obstructed by structures, vegetation, or other obstacles that would impede access. While an automatic disconnect is not explicitly required, the accessibility of the manual disconnect is paramount. This allows for quick de-energization of the pump in the event of a malfunction or during maintenance activities. Furthermore, proper labeling and signage should be provided to clearly identify the disconnecting means and its purpose. Now, let's move on to a more detailed discussion of National Electrical Code Section 682.33, which focuses on equipotential planes. An equipotential plane is a critical safety measure designed to minimize the risk of electric shock in areas where electrical equipment is used near bodies of water. The fundamental principle behind an equipotential plane is to create a zone where all metallic objects and surfaces are at approximately the same electrical potential. This eliminates or significantly reduces the potential difference between these objects, thereby preventing electric shock hazards. Section 682.33 subsection A mandates the creation of an equipotential plane of the service equipment, in addition to the grounding electrode system required by Section 250.52. This means that the service equipment must be connected to a grounding system that is supplemented by an equipotential plane. The purpose of this requirement is to ensure that any fault currents are safely conducted to ground, minimizing the risk of voltage gradients that could pose a shock hazard. The equipotential plane is typically constructed using a grid of interconnected conductors such as copper wires or a metal mat that is buried beneath the surface or embedded in concrete. This grid is then bonded to all non-current carrying metal parts within a specified distance of the equipment, typically 6 feet, as stated in Part C of Section 682.33. The connection to non-current carrying metal parts ensures that these objects are also brought to the same electrical potential as the grounding system and the equipotential plane. This includes metallic enclosures, fences, handrails, and other conductive objects that could be touched by individuals in the area. The equipotential plane must be connected to the grounding electrode system, which consists of electrodes such as ground rods, ground plates, or concrete encased electrodes. This connection provides a low impedance path for fault currents to flow to ground, ensuring that overcurrent protection devices, such as circuit breakers, will trip quickly to energize the circuit. While Section 682.33 does not explicitly require the bonding grid to match that of Section 680.26 subsection C, it does emphasize the need for a low impedance path for fault currents. The design of the bonding grid should take into account the specific characteristics of the site, including the soil resistivity, the size of the area to be covered, and the potential fault currents. Acceptable methods for creating an equipotential plane include using a metal grounding mat, which is a prefabricated grid of interconnected conductors that can be laid out on the surface or buried beneath the surface. Concrete encased electrodes, which are reinforcing bars embedded in concrete, can also be used to create an equipotential plane. These electrodes provide a large surface area for contact with the earth, ensuring a low impedance path to ground. A metal grid buried beneath the surface is another common method for creating an equipotential plane. This grid can be constructed using copper wires or other conductive materials, and it should be buried at a sufficient depth to ensure good contact with the earth. In summary, the equipotential plane is a critical safety measure that should be implemented in both the control area and the service equipment area. The plan should be designed to provide a low impedance path for fault currents and to minimize any potential difference between metal surfaces within the restricted area. The plan should be connected to the grounding electrode system and to all non-current carrying metal parts within 6 feet of the grade level adjacent to the equipment. Now, let's further clarify the requirements for grounding and bonding in the context of submersible pump installations near bodies of water. Grounding and bonding are essential safety measures that protect against electric shock hazards and ensure the proper operation of electrical equipment. Grounding refers to the connection of electrical equipment and systems to the earth, providing a lower impedance path for fault currents to flow to ground. This helps to stabilize voltage levels and prevent the buildup of dangerous voltages on non-current carrying metal parts. Bonding, on the other hand, refers to the connection of all non-current carrying metal parts together, creating an electrically continuous path that minimizes voltage differences between these parts. This helps to reduce the risk of electric shock by ensuring that all exposed metal surfaces are at approximately the same electrical potential. In the case of submersible pump installations, grounding and bonding are particularly important due to the proximity of water and the potential for electrical faults. The National Electrical Code provides specific requirements for grounding and bonding in these types of installations, which must be followed to ensure safety. Section 250.52 specifies the requirements for grounding electrodes, which are the means by which electrical systems are connected to the earth. Common types of grounding electrodes include ground rods, ground plates, and concrete encased electrodes. The choice of grounding electrode depends on the soil conditions and the size of the electrical system. Section 250.92 requires that all metal enclosures, raceways, and other non-current carrying metal parts be bonded together to create an electrically continuous path. This bonding must be accomplished using approved methods such as bonding jumpers, bonding lock nuts, or other listed fittings. Section 682.33, as previously discussed, requires the creation of an equipotential plane in areas where electrical equipment is used near bodies of water. This equipotential plane must be connected to the grounding electrode system and to all non-current carrying metal parts within 6 feet of the grade level adjacent to the equipment. In addition to these general requirements, there may be specific requirements for grounding and bonding of submersible pumps and related equipment. These requirements may be specified by the pump manufacturer or by local electrical codes. It is important to consult with a qualified electrician to ensure that all grounding and bonding requirements are met. Now, let's consider the specific scenario of a 15 horsepower submersible pump located in an artificially made body of water running a fountain. The pump is operated and controlled from the mainland, and the control equipment and pump disconnecting means are located on a 5-foot by 5-foot concrete pad approximately 10 feet from the shoreline. The service equipment supplying this control equipment is located roughly 50 feet away. In this scenario, the following electrical requirements would apply. Firstly, the service location must comply with Section 682.11, which allows for the installation of service equipment in specific areas near bodies of water, provided certain conditions are met. Secondly, the control equipment must be readily accessible for disconnection, as required by Section 682.13. This means that the equipment should not be obstructed by structures, vegetation, or other obstacles that would impede access. Thirdly, an equipotential plane must be created in both the control area and the service equipment area, as required by Section 682.33. This equipotential plane must be connected to the grounding electrode system and to all non-current carrying metal parts within 6 feet of the grade level adjacent to the equipment. In addition to these requirements, the following best practices should be followed: proper grounding and bonding of all electrical equipment and systems. Use of ground fault circuit interrupter protection for all circuits supplying power to the pump and related equipment. Regular inspection and maintenance of all electrical equipment and systems. Proper labeling and signage to clearly identify the disconnecting means and its purpose. Consultation with a qualified electrician to ensure that all electrical requirements are met. By following these guidelines, the safety and reliability of the submersible pump installation can be ensured. To recap, understanding the National Electrical Code requirements for submersible pump installations near bodies of water is essential for ensuring safety and compliance. While an automatic disconnect is not always required, the accessibility of the manual disconnect and the creation of an equipotential plane are critical safety measures. Proper grounding and bonding, along with regular inspection and maintenance, are also essential for preventing electrical hazards. Consultation with a qualified electrician is always recommended to ensure that all electrical requirements are met and that the installation is safe and reliable. Keep in mind that local codes and regulations may also apply, so it is important to check with the local authorities to ensure compliance. The information provided in this narration is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician to ensure that your electrical installations are safe and compliant with all applicable codes and regulations. Also, note that the National Electrical Code is updated periodically, so it is important to stay current with the latest version of the code. The specific requirements discussed in this narration may be subject to change in future editions of the code. Therefore, It is always advisable to consult the most recent version of the National Electrical Code and any applicable local codes before undertaking any electrical work. And remember, safety should always be the top priority when working with electricity. Always take precautions to protect yourself from electric shock hazards, and never attempt to perform electrical work if you are not qualified to do so.